Ladies and gentlemen, delighted to have your company. We've got a profound topic at hand. As the master says, redesigning energy, new technologies powering the transition. Now, within that scope, you look at IoT, you look at predictive analytics, you look at AI. We're looking at a high-powered industrial complex, which is sort of underpinnings of it, or we hope, we imagine, would be by the via digital technologies and AI playing a huge part of it. We've got a all-star cast here to discuss that, if I may say so. Joining us is Gary Jordan, who's the founder of Leaps and Bounds, Ulrika Weising, who's a senior energy industry executive at Shell, Centrica, and so on. We'll find out what your next move is fairly soon. We also have Applied Computing's very own VP of Operations, Eliza Edison, and of course Fred Desson, founder and partner at Stride VC. Welcome to all of you all, and many, many thanks for joining us for this profound discussion. Fred, before we lay out our stall, before we delve into this topic at hand, if I may turn the floor over to you, just sort of give us a flavor of, what AI is all about and its significance for the industrial complex, and of course, some of the opportunities you see on the horizon.
Yeah, with pleasure. So I think there are two risks here. One is to limit your conception of AI to ChatGPT and what the LLMs are doing for us in terms of knowledge work. And the other one would be to only look at what Orbital is doing. So if we think about AI a little bit more broadly, there are two fundamental things that happen. One is we realized that expert systems, as we designed them in the 90s, started running into the limits of what we humans could model, and that treasure lay in the data, so to speak. So in the beginnings of big data and machine learning, we just basically turned it over to machine learning models to try and learn inference in a way that humans couldn't cope with. And now, of course, we're far down the line on this. Secondly, so expert systems being replaced by machine learning would be wave number one. Wave number two, I think everybody got blown away by what scale could achieve, which is not intuitive. So I think when OpenAI started playing with ChatGPT and give it more compute, more data, and more memory, it just kept on breaking through performance barriers. And to this day, we're still looking at brute force scale as an incredible tool. So the point about this little opening is to just invite everybody to think about AI broadly. It could be computer vision to analyze pipeline data leaks. It could be complex data modeling to avoid mud blowouts in a drill head. It really is very broad and it applies all across the stack. So material science would be one, battery chemistry, upstream operations, like I mentioned, where to drill, how to avoid incidents whilst drilling, pipeline management, and then things, of course, like operational efficiency, predictive maintenance, full refinery optimization, which is what Orbital does today. And then, of course, some of the big areas, which are things like grid management. And it's worth remembering that when Google bought DeepMind, they bought them for 550 million pounds, if memory serves me well. And I think they paid that back in the first year just by doing data center energy optimization. That was the first implementation of DeepMind post-acquisition. So it started in energy, and here we are back in energy. And then, of course, there's some people in the room who do energy trading, everything that has to do with data optimization, trading optimization, and actually everything that's downstream of production itself, but has to do with transport, trading, pricing, and so forth. So it really applies all across the curve, whether that's computer vision, whether that's narrow model, whether that's large models, et cetera, et cetera. It's just absolutely everywhere. If you're getting confused because of the hype cycle and the adoption speed, if anybody's in doubt, I mean, AI is not mobile. It's much bigger than anything we've ever seen, and this is it's an infinite opportunity. It's coming, and then I wouldn't get distracted by issues with adoption or is it hyped? Sure, it's hyped. That's what VCs do, but the wave is profound and all transforming.
Lisa, over to you as you embark on your applied computing journey. What sort of opportunities do you see on the horizon?
I think what really drew me to applied computing, its work, its team, and the mission is the how hard the problem was, that it was applying to tough technology and that it had a sophisticated approach to it. Instead of some of these earlier examples, the more common colloquial examples of AI that Fred is talking about, that we all know as ChatGPT or a customer service chatbot or things like that. Those are important and relevant and useful technologies, but what really motivated me was how complicated and urgently necessary what we were building here was.
Sure. Riga, over to you. The masthead says energy is not just constrained by downstream. So what do you see the wider applications around the energy spectrum?
I mean, I think we've seen in the last few years quite a revolutionary acceleration of new technology in this space, and we're talking about hydrogen, we're talking about carbon capture, as well as of course with the digital space that is revolutionizing things, and just anything. If you think about solar panels that are monitored by drones to make sure that they're cleaned and optimized on a daily basis, to if you look at carbon as a whole, methane emissions that are being monitored by satellites and dedicated people going out to where they see the actual leaks and optimizing that. So, there's just a massive opportunity still. So we've seen a lot, but there's still a massive opportunity, especially when it comes to efficiencies and that heavy industry nut to crack, because it's heavy industry, is such a big, it's 20% of our emissions, and it's such a big nut to crack, and we've barely scratched on the surface.
We're barely getting started. That's Ulrika's verdict. I suspect you concur, but I'll let you speak for yourself.
Yeah, so I'm going to come at this from a lived experience. So I've grown up in big petrochemical companies, and then in the last 5 years I've also been on the ground with manufacturing companies, both large scale, mid-sector ones, but also mining and also water, power and technology companies. And what I see happening is huge breakthroughs in pilots. So lots of pilots happening, sensors being deployed, lots of really great experiments that have been really well thought through, return on investment modeled, stakeholders brought in. But then when I go onto the ground, you go to those brownfield sites, the lived reality is slightly different. But what excites me is I know that the potential is out there. And again, CCS projects, I've seen some of these in action, I've seen the potential out there. It's a little bit of time delay, I think, for some of this stuff to get out there, and for the wider set of people in these big organisations, big, dirty, heavy industry, to understand what the future holds and how they can use what's being thought about, designed in the corporate headquarters out on the field.
See, Liz, over to you. Carrie's talking about the disconnect between potential, the actual potential, and of course, development, what we see on the ground. So, what are your feelings on that, and what's your sentiment on that? The direction of travel from here, say in 5-year increments, if you don't go too far into the future.
Yeah, so candor demands that I confess this is my 6th week of employment at Applied Computing. So most of my anecdotes from implementing improvements and technologies in heavy industry come from lifetimes past. But what I see what I have found time and again is that human beings are the most complicated machines. That you build these sophisticated technologies, but really embedding them in the workflow of users, understanding how they think and who they are and how they approach problems really is the differentiating factor between a very nice idea that you might publish a white paper about and a solution that actually transforms an industry. So looking out 5 years, it's going to be the businesses that are really paying attention to their users, embedding in their world and really understanding it as from a first principles basis before they begin designing the tool. That'll really set the market apart, I think.
Sure. Rika, your thoughts in the same slant?
Yeah, I think, I did or tried to do something similar to applied computing in 2012, using data mining and algorithms to try to help industry be more energy efficient and implementing those in the operating rooms with the control room centers. And the potential we saw then was, a 20% decrease in energy consumption in real time without much investments, just by changing the way people were operating the plant. But we failed back then because we weren't able to translate this black box into something that people could truly believe in and truly understand. And therefore, this idea of bringing first of all, being able to develop a physical model of a system quickly, and then bridging that with algorithms and type of smart intelligence and recommendations with this large language model can bridge that potential that we saw back then that we were unable to capture. And we spoke about this over lunch, but actually the best way to save energy in a manufacturing plant or a process industry is to never shut it down, as in the uptime. So 20% energy efficiency if you run all the time, instead of shutting it down and starting it back up. So avoiding problems in operations and making sure that the plant is operating is a tremendous way of saving that 20% of energy without actually much investments. You don't need any physical investments per se. So that potential is still out there to grab. We haven't done anything. I mean, I was doing this 13, 14 years ago. We haven't advanced much since then. So the fact that we have the computing power, we have the tools now to do this is very exciting.
Fred, if I may turn the floor over to you, but tweak the question slightly from a VC's perspective. You heard Callum early in the morning saying, there are opportunities out there. For a person like you who's investing in this sphere, when you look at people talk about opportunities, but also offer caveats in the form of complexities in terms of deployment, what colors your thinking when you seek companies to back in this sphere?
Yeah, I'm going to throw two ideas out there. Number one is, so I'm a seed investor, so we go in early. The one thing we can never defend against is market timing. If it takes 5 years for something to come to fruition, we're dead. So I cannot afford to take market timing risk. I can take all sorts of risks, but that one is terrible. So what makes me smile sometimes is I listen to these consultants from C3 or Palantir or whatever, and they're like, hey, all we need to do is completely rebuild the data infrastructure from the ground up, and can we please have data lakes and avoid data silos and modern APIs, etc. And then I see graphs of a SCADA system, and I'm like, okay, so how much time do we have? Do you have 30 years to do this? So the first thing you're looking for is to avoid making unreasonable asks of the industry in terms of modernizing the core of how data functions. There also seems to be a misunderstanding that somehow Saudi Arabia is going to connect its plants to the cloud. I mean, these are strategic assets. It's kind of never going to happen, right? So you're looking at these environments are constrained in more ways than one. And so for me as a venture capitalist, I'm like, well, I'm not here to go change the world over a 100-year period. I'd like to build a company that could have impact within a defined time frame. So the beauty of something like this is, Sam goes on a Friday at 2 p.m. inside a control room. He plugs into the historian. He gets 15 years worth of data, and by 4:30, he's running optimizations. I'm like, okay, that's cool, right? Like we can build a business around this whilst we're having impact. The other thing I find is interesting, more as a general point, is AI cannot fly blind, and in industrial environments, it's kind of flying blind. So if you're feeding the world's entire culture into an LLM and you're asking it to do vector embeddings and to do representations of our knowledge, okay, that's easy enough. But now imagine if your brain had no sensors, right? And our brains are inference engine. By the way, I learned recently that they actually impact the way our senses function too. So in other words, we build controlled hallucinations of the world, which is kind of interesting. But anyway, we are flying with AI that has no capacity to see or sense. Now, in refineries, you have the benefit of sensors. They already exist. And I think Sam explained, hey, you're running on 8% of your data, not 100%. In industrial environments, there are typically sensors, but they're not connected. So how are we supposed to do anything, right? So I think step one is to create a fabric of sensing. Now that fabric of sensing then generates an additional problem, which is, oh, now we have chaotic time series data because the real world is messy, it's non-predictive, data's patchy. I mean, it's horrible. So now we need artificial intelligence specifically designed to handle chaotic time series. So that's like a whole nother category of AI type, which, Amazon, Kronos, and things like that. There are people that have been working on this for a while, but I find that also interesting to look at this as both a challenge as an opportunity, which is how do we allow AI to sense? And that's part of the reason why I think we haven't seen what AI can do, because so far it's been operating. It's like your brain is shut inside your head and you have half of your left eye working. What happens when, you can feel the blood in your hands and you're fully in touch with your environment. So I'm excited about that. Yeah, don't know if I answered your question correctly, but these are the two thoughts I came.
Now that what you saw on the operating horizon, please.
Yeah, so what Fred just said for me, so I'm a practical, on-the-ground person working with large, mid-sized corporates and seeing day by day the pain of some of this, but also having had a background where I've also seen 5 years ago what AI could do. So when Fred talks about this, I do find it inspirational, because the lived example of that is when you go onto a site, be it a manufacturing floor, be it in a big water processing plant, be it at a mine in Chile or in Democratic Republic of Congo. You look at what's there, and they do have sensors, and they have deployed quite a bit of AI, but it's a little bit hidden away, it's hard to unpick. But you look at what people are doing day to day, and you go into the control room, look at SCADA, and it is quite backwards. And you do feel, as somebody going on site, and I look at sustainability and help with ESG strategies, where on earth do you start here? Because like you say, when you talk to people, they're going, we're going to need 5 years to bring our data together and get the right data foundations. We're, particularly in mining, it's highly acquisitive business. They've just brought a new massive asset, and then they've got the problem of all of that data. So to be able to think, and I haven't seen Orbital, to be able to think that there's some kind of layer that we can put on top of this that immediately works, that within hours, days, people can start to get different insights to make decisions. That's what the breakthrough is, because I'm not the only one, and I know a little bit more about technology than your average operator and processor on the floor, but very much the mindset out there at the moment is this is going to take 10 years to change. Please stop talking about digital. There's the door. Have you seen how we're working? And some people with flip charts walking around, yeah?
I feel like rebounding on that, because it gave me another thought. We come from a world of enterprise software, which was painful and slow and had interfaces, and the interfaces needed to be rolled out and people needed to be trained. So that's the paradigm we're still thinking in.
Yes.
But actually with agentic, you could have AI running in the background, humans being completely oblivious to it, and the thing adapting to whatever interface you're in and delivering the piece of information or piece of data that you need at the time as you need it. So I think it's kind of, for me, we're probably going to move towards something that resembles more like ambient computing or ambient intelligence. And if we have to fit within legacy applications, that's actually easy to do. Products like UiPath or cognitive automation, where we can just plug into existing SCADAs, and actually over time, I'm not saying this is going to happen right away, but I think we're probably going to move away from this idea of like, oh, we need to move large silos of software that people need to learn how to use, to something that sort of operates across the existing fabric and just delivers the right information at the right time.
And I think for me, one of the things that is exciting is this ability to process unstructured data. That to me is the key in all of this, because you have meeting notes, you have,
Operator logs,
you have Excel spreadsheets that, might sit on one person's computer and not shared, right? You have all this unstructured data that today we actually have the technology to cipher through all of that and take out the intelligence and really give the right information at the right time to the right person. So that's exciting, because we haven't been able to deal with unstructured data before. And that's really, I think, a key element in this success.
Liz, you have a view on the subject, or I could just move on to what I was about to ask you, which is kind of tied in. We've sort of all panelists, you fellow panelists, have alluded to that. That sort of seems like the elephant in the room, the age-old idea of legacy infrastructure. If you're talking about legacy infrastructure here, it begs the question: is a legacy mindset then holding us all back?
So if everyone will indulge me in a trip down memory lane to rural North Carolina in the summertime, for those of you who have never been to North Carolina in the summertime, you have to imagine being quite warm. I was in a trail mix factory. For those of you who aren't American, trail mix is those bags of peanuts and raisins and M&Ms you buy at an airport. And my job was to drive operational improvement in the roasting room, so even hotter than it was outside. Anyway, long story short, there was this one machine, we needed to run peanuts on it. There'd been a crisis, there'd been a failure, a safety failure years ago when they tried to do it, and so no one did. It was like touching the third rail to even suggest it. So it was weeks of conversations with the original equipment manufacturer and with the team and with the quality folks and with the plant manager and controlled trials and safety signing off 3 different times. And we finally ran the test and it worked. It worked beautifully. I felt triumphant. I sailed home on my Thursday night flight like any good consultant, and I came back on Friday in the office. I presented to the team, like, we can now run it at 7 instead of 3 on the dial. It's so good. It's safe. We're saving lots of money. Aren't I clever? And then I came back on Monday morning and the dial was back at a 3. And of course I gasped. And I'm like, this is so antithetical to everything we've been talking about. And I went to the operator, who I'd built a very friendly relationship with in the time that I'd been there. And I said, why on earth is it at a 3? Did something happen over the weekend? And he said, well, no, 3 is just where we always had it. Like months of work. And that was the moment that crystallized for me. If you're not changing their mindset to believe that what they are doing can and should change and that they should go along with that change, you're never, like, all of your clever little math is going to get you nowhere.
I think this is, what we were talking about over lunch as well. It's, it's technologies, processes, and there's people. And if you don't get all 3 right, you're going to fail. And, and when it comes to people, I mean, I was in situations, go back 14 years when I was trying to do that. And we had workshops with the operators. You have to remember, the people in the control room, they probably don't have a high school diploma. They've been there as, they started as a trainee and they've been working in this plant for 30 years. So they know the equipment inside and out. But they do what they've always done, and changing that behavior is really hard. But take it one step further. I actually had situations where we couldn't run the workshops because the union didn't agree to do it, right? So there's processes. So there's, it's the people, it's the processes that we need to get right. Otherwise, we won't be able to deploy this type of technology. It's winning the hearts and minds of people, ultimately. And that includes the people in the union, right?
Yeah. And I think with technology, process, people, we know that AI is not going away, and this can leapfrog, that old ERP, enterprise resource planning mindset, that it's going to take 10 years and it's going to be painful and you're going to have to spend a fortune with Accenture to bring them all in to do that. And I think with people, it's a really interesting one. I've worked a lot with HR directors in the last 5 years, and it's almost looking at the people and the operating model in a company, the people operating model of the company, differently, because if technology is going to change this so dramatically, what does that do for people's, it's all this philosophical argument, what does that do for people's jobs? But you can rewire these industries, that these people using SCADA, to then that will drive the process change, right? But you kind of work people backwards with the change which AI leads, rather than people first, then what processes and tech do you put behind them?
Absolutely. Ladies and gentlemen, we're going to turn the floor over to you in a few minutes to get some questions that you may have for our eminent panelists. But before that, I think I might want to ask all 4 of you this question. It's in our masthead, talking about the technology-driven future when it comes to the energy transition, when it comes to sustainability, and improved efficiencies and improved throughput and a lower carbon footprint are joined at the hip. So peer into your crystal ball and sort of tell us, what a technology-driven, sustainable future is gonna look like. And I'll start with you, Kerry, if I may.
Look, I'm not a deep technologist. I'll leave that one to Fred to answer. I guess something to do with quantum computing or something. I don't know. But I am deep in sustainability. So one of the difficulties I have daily is I do a lot of work on carbon footprints, and not, where we're working with big, large-scale corporates and industry companies, you do have the luxury of huge teams of people and lots of spreadsheets and lots of BI layers on top of it running these carbon footprints. But honestly, I'm a little bit of a cynic out there at the moment. If I'm working in small to mid-sized companies, and by the way, the UK and many other countries, the heartland is these family-owned mid-sized companies. And for them, it's like they don't have all of the infinite money in the world to indulge in digital. So how do you do their carbon footprints for them to make a difference in decarbonising themselves? And this is what I'm really interested in Orbital for, because at the moment that's so hamstrung. We're using spend data to look at carbon footprints. You get virtually no insight. And there's a lot of platforms out there, I mean, kind of just looking at carbon, where I think, well, 5 years ago, there should have been some kind of AI layer on this to tell you what is your next best decision based on this data, or to link the carbon footprint and the emissions calculation to cost savings, to profits. It's the first question FD's asked me for, and there's very few. There's a very crowded marketplace of lots of people coming up with lots of good carbon calculation engines, selling you the world. But not very many of them am I seeing actually getting to the bottom of the commercial equation. And my last point on this, you can tell I'm a bit of a cynic about these things. I've had some pain with it in the last years. My last point on this is trying to measure and do carbon emission accounting, mid-sized company type work, is kind of a fool's errand at the moment. And that's because you're doing it in a silo. So how many CEOs and how many FDs do you know that's going to sign off 50 grand for a team of consultants to come in to kind of indulge them on their checkbox of ESG reporting? They may have regulation where they need to report, but to do it in a silo, what I would love to see, just like I integrate ESG strategies into the heart of a corporate strategy, is your carbon data and your footprint and your emissions should automatically be coming out of your SCADA type control panels, right? If you're measuring the machine, you should have all of that insight. You should then be able to equate that, like I said, to costs and to profits. So that's I'm going to get off my soapbox now, but there we go. That's sustainability, and there's a huge, the ESG kind of domain of measuring carbon, there's just a huge potential there that it comes in with the rest of the data.
I mean, it's interesting, just what you're saying. So I used to work for a company called Valorec, and they produce seamless steel tubes that are used mostly in oil and gas, but also to transport hydrogen or CO2 or inject them into wells or what have you. And they have about 600 different products, and it's different steel grades, it's different surface treatments, it's different. And we were trying, and I emphasize on the word trying, to calculate the footprint per type of product in real time, so that, because we actually printed a barcode on all of our tubes that gave them the information where it was produced, and what it was and who was the customer and all. It was a barcode. So we could put any sort of data in that barcode. And I actually started this project to say, okay, so if we can also embed the carbon footprint on this individual tube by taking all the data that has been, in the manufacturing process, because we had this tracing, we knew exactly where the steel was coming from, we knew exactly what we had done to it throughout the manufacturing process. And I literally started a pilot project to try to do this, and we couldn't do it because we had a number of system that was just SCADA controlled or connected. So there was no historian that was storing the data. It was just in the control room in real time. So we actually weren't able to do that. So how can you then take intelligent business decisions where you don't have the right data in front of you when it's linked to sustainability? Because ultimately, I'm also a firm believer that sustainability has to make business sense. Otherwise, it's not going to happen.
Yeah.
But if we're unable to link the sustainability data to the business decision, where are we? Like, what are we? So maybe this is a bit of a gloom ending, but I do believe that once we crack that nut, we can take the right business decision for the right carbon, decisions that we need to make in order to improve sustainability.
I don't think that's gloomy at all. At Applied Computing, one of our core values is good information, not good news, right? And this is incredibly useful information, and it's what Cal was talking about in his first talk, that there's no one of our partners, no one of these industries doesn't want to stay with the times and make ESG progress and do what we need them to do, but they can't do it if they can't do it profitably. And this is the most consequentially under-optimized industry on earth. I'm now parroting Cal. You already saw the first talk. Shut up, Liza. But this is the crux of the issue. So I don't think that's doom and gloom. I think it's a very clearly defined problem. And hard things are hard, but we're excited about it.
Yeah, I was trying to think about this real time a little bit. So what came to mind is one. Let me start with a quick anecdote. I once found myself in a ex-helicopter army base in the north of Sweden. And the reason why I was there is because it was a giant Bitcoin mine. And the Bitcoin mine used utility computing. So they're basically dirty data centers. Every time a component breaks down, you just throw it away, and ran these enormous chips, right? Like these big 14 nanometer GPUs that were Bitcoin mining. And this thing was generating heat all the time, which is why we're up there. And whenever the heat was too much, they'd open the side doors and allow the heat to come through. And basically the Arctic winds to kind of take the heat away. The reason why I mentioned that is because now we're building much larger compute facilities. I mean, you've seen Colossus, on which Grok 3 runs. You've seen the big deals that Saudi's just done. So anyway, we're heading into a world where access to energy is become geopolitically even more important. Artificial intelligence is a geopolitical domination tool. If somebody builds a 12-month head start, it'll be game over on a global basis extremely quickly. So that's just become interesting. On top of that, we know that since the energy crisis with Russia, we are relying on mission critical infrastructure that's creaking at the edges, right? In Europe in particular. And so that's a geopolitical constraint. And so what came to my mind was, wouldn't it be nice if we could switch this narrative around dirty energy to, let's first of all optimize the shit out of what we have, and let's sell that as a very positive message to the market at large, which is we are here to power lives and homes, and we're going to do this 20% more efficiently or 40% more efficiently because we are strategic assets that deliver what you need, and artificial intelligence can help us do that. I find carbon, I scratch my head at carbon because, hey, we're using industrial solutions to capture carbon to solve for industrial solutions that we use in the first place. I mean, there's something that I find inherently absurd would be a bit of a strong word, but it's a bit of a Sisyphus task. And again, so I'm like, can we use AI to optimize how we produce, consume, distribute, etc.? Like, wouldn't that be nice? So where I'm most excited, and actually I think it's very tangible. So where I'm most excited is grid optimization, demand optimization, production optimization, etc. And I think we should throw everything we have at this. I think it's a geopolitical problem that the EU should be screaming about, not just renewable energy, but how do we make our strategic resources secure and efficient? And I'd love to be part of bringing that sort of narrative, which is, fossil, etc., got us to where we are, thank you to our beloved ancestors. And it's the most powerful, productive assets we have for energy. And artificial intelligence can help us make it better, safe, secure, and ours. So that's where my mind went in terms of where we can apply AI productively starting today.
Ladies and gentlemen, if I may just turn the floor over to you. If anybody here has a question for one of our eminent panelists, if you could just say your name and your organization and which panelist you want the question addressed to you. We're in a small room, so we could do with the mic, but here we go. Well, I guess we're making a recording, so you know you'll be crystal clear on that one then. There you go.
A lot of the conversation.
Sorry, could you just say who you?
Sorry, forgive me. So Mark Hurren and Hope. So a lot of what you guys have spoken about has been this where the tech meets people. And Fred, I completely agree with your take on the current situation. It doesn't work, but it's probably one for you, Eliza, in terms of how are we rolling this out so this makes sense to the other panelist clients, because this is a constant issue with all tech, not just AI, but just this where it meets the ground. How do you get really long-standing legacy-based companies to engage with this? Because there's been a lot of talk about trust throughout this whole presentation. Trust is perceived, and it's how we get over those barriers and start to roll this out. And then one as an aside, sorry, two questions, was do the sensors actually exist right now? Is the infrastructure, the physical sensors out there to collect this data, or are we actually having to retrofit physical items to start to collect this data?
So it's a two-part question. First part about infrastructure, and I was so focused on that one. Your first one was how does the rubber meet the road? How do we actually infiltrate these large? Yeah. Okay. So I spent some years at Palantir. And what we learned there was the necessity of finding a really valuable initial use case that would win champions in an organization and spread from there. So you simply can't boil the ocean, right? You have to find one mission critical thing that they cannot solve any other way, show them the power of the tool, win champions, and then spend time with them desk side, right? Watch their day-to-day workflow, make sure that the tool, like the parable at Palantir was always the difference between DSIGs, which is what the Army developed for its analysts, versus Palantir's Gotham. Like there's all these images they would talk about this tool that had been brute forced from top down, hadn't actually considered the users in their day-to-day workflow, and so they used it as a footrest or a standing desk boost for their laptops on which they would run Gotham. And so the difference there was Palantir engineers would code side by side with Army analysts in like forward operating bases, and that's the principle we're really trying to build here. Not that to say we're a Palantir 2.0, but a similar enterprise thinking is here, right? Find that really valuable use case and expand from there. Let the value of the work speak for itself, and let our users be our champions.
So let me add a thing on this. There is somebody within the organization who has a job to be done today. It's the advanced process control engineer. Those teams. They spend months refining machine learning systems that they then put into production and start degrading day two. So that's your champion, and the key is, can we empower you without needing to touch your infrastructure? Because the moment we need to start touching your infrastructure, we're dead. That's the insertion point. So that's the equivalent to the Palantir intelligence analyst and forward deployed engineer working step by step. So here it's like, you have a job to be done, Mr. APC engineer, and we're going to power that up without touching legacy. That's the game, and you'll see the demo.
And maybe the second question, which was sensors. Yeah. So a lot of industry today have lots of sensors, and they are connected to data historian that stores the data, so the data is there. But there's still a lot of equipment out there that only has a SCADA, which is maybe saves 30 minutes worth of data. So you actually don't get the data over time, and that's a problem.
So nobody's looking at it at all historically.
They just use it in real time in the control room. That's the only time they look at that data, in real time. So that's a problem. So you need to connect them to some sort of system that stores the data. But typically the sensors are out there. And if the sensors aren't there, especially electricity sensors might be less spread out in heavy industry, but they're really cheap. They're so cheap to put in that is not a hindrance to get stuff done. The hindrance is those old SCADA system and actually connecting them to data historian. That interface is tricky, right? But it's doable.
And part of what AI does, by the way, so if you have, say you're in a refinery and there's 5 sensors per meter of pipe, that data may be stored locally and not brought back to home base, right? Because you also need to move that data and there are pretty limited networking infrastructure in there. It may also not be necessarily collected systematically all the time. So this is also where artificial intelligence helps, because you can recreate synthetic data sets to complete what's incomplete. And then you can build local models so that you can move model parameters instead of the actual data. So then you get to models of models that are consuming the local model that's been built instead of the entire data set. Because again, these are Faraday cages with limited networking capabilities. I mean, there's a whole set of issues that you run into in the physical environment. But artificial intelligence, so we're talking about federated learning, models of models, synthetic data sets, etc. All that combines together to help you recreate data visibility in a way that you didn't have before. So this is where you're really talking about multi-layered, it's a full stack, right? Federated learning, model propagation, etc., back to master models, without sending any data back to the cloud, because you can't do that, right? Correct. There's too much data and it's too sensitive, so you can't ship it to the cloud. So that's part of the physical constraints we're talking about, which is why you cannot innovate on a single dimension. You kind of have to go solve the whole enchilada at once, right? I need federated learning, I have sparse data, I have sparse compute, I can't go to the cloud. Oh shit. Right? Yeah, that's the problem, exactly.
And also, of course, AI can really help in the very beginning. Like the first step is to identify, where do I actually need data? So that you intelligently invest in the right positions for where you need critical data if you don't have it already, right? So that's the kind of first step, is to...
So digital twins.
Yeah. Well, yeah.
Yeah, so now you build digital twin environments, cool, and then can you model them with proper physics engines so that before you've even put a shovel down, or it might be your existing refinery, you can fully model the thing with physics models that make sense, or fluid dynamic models that make sense. So now I'm like, okay, cool, now where do I need sensors, right? So now you see the whole thing is starting to work together.
Yeah, it's clever.
Do we have another question?
We're excited, we're excited.
Yeah. Gentleman there.
Hi, Riccardo. No, just to add up to
Sorry,
what
who
you
are
said.
you with?
Riccardo Moscara, I am entrepreneur. So just to add up to what the panelists said, which was amazing and related to his question, I would say that there are two different dimensions. One is IT, that all of us were speaking about. The other one is completely different, which is change management, and no one is talking about. Change management is something that everyone should understand, because companies lose billions just because they don't understand psychology, they don't understand change management. When you have a new tool, in this case AI, just as I said to Sam before, you have to understand that it's, and also like all of you agreed on, it's a matter of people. You can have the best idea in the world, but it must be used by the people, right? And so change management is just the process which happens before, during, and after the change, is a transition. You need the support of the company and the sponsor that is promoting the project. You need to show the authority so people can trust you, as you said, But most of the time, companies fail. Ask Benetton, for example, who lost $500 million 20 years ago when they invested $1 billion for the project of building sport clothing, Anyway, it's all about understanding what's in it for them, so for the people who have to use the technology, and not just focusing on the business objective, because this is the problem. Companies most of the time say, we have to do this because we save 30% of money. It's all the company perspective. But the people that have to use that technology just don't understand how this technology can improve them. And so, for example, as I said before to Sam, in order to build trust, you should focus on UX, focus on making everything understandable, making everything clear, making everything easier and faster for the people who have to analyze and approve all the data or the change that is proposed by AI. Because again, AI must be used in collaboration with human beings, not just as substitutes, right? So sorry for speaking as a panelist, but that was the idea.
I think, by the way, I think all three of the ladies made the same point. But
It's about making things clear and bringing people along for the journey.
It's winning hearts and minds. Absolutely. Was there a question in there?
That's what we were.
No, the question is, companies should invest more in change managers, and most of the time they only speak about IT, but almost no one, says, okay, but should I invest also in change managers? Because this is the point. If you just invest on IT, making something as a solution, for something, but you don't have the people, change managers that help to push.
Speak,
yeah,
basically.
yeah,
Going beyond management speak.
I mean, so I was telling you about how I used to do this 14, 13 years ago. And we applied change management because it was the only way to do it, using Cotter's wheel of change and, and change takes time. And this is where, sometimes corporates are quite impatient and they expect the change to be permanent after 6 months, whereas change takes 5 years to be permanent, kind of thing. But you're absolutely right. I think maybe it's just the forum that we're not talking enough about the change management. I think most business leaders are conscious about the change management that is necessary to capture the business opportunity that is there. Do you not agree?
Yeah, I agree totally. I mean, I've made a lot of my career and my job out of change management. And it's that kind of almost legacy thinking of what it looked like 10 years ago. What's interesting is there a paradigm shift with this stuff? Like I've experienced with ChatGPT, it's now I hardly do an email without pushing something through it. No one's managed me through that. So I don't know, because AI comes along, and if you're an advanced process engineer and you're suddenly able to make different decisions and you've got this data coming at you and it's making your job easier, do I need to sit there as an advanced process engineer and be persuaded and pushed through training courses? I don't know, because I don't know your product well enough. But I'm not sure about that. I think people, when it makes their jobs easier, where it gives them space to then do probably the more value accretive things they do, then, perhaps that change cycle and the adoption of change, going back to Kotter, whatever it is, create a sense of urgency. Perhaps Kotter's 7 steps becomes 1 or 2.
As a starter, by the way, I want to highlight we have an ex-Palantir person. Palantir is legendary for staying under the radar and going in and sitting next to the users for years, trying to understand how intelligence analysts produce their reports. And it's a beautiful example of field deployed engineering and design.
And then
to the user.
You get what we would call lock-in. All of a sudden, they just can't live without you.
Yeah. But yeah, I mean, you're right. Look, it's the number one issue, and I think you guys have scars on your back from trying to make that happen. Right?
I want to offer a small disclaimer that when you said the importance of explaining your work and meeting the user with where they are, I did not pay him 10 quid to say that. I'm going to give a demo in 20 minutes, and I think you will see that we thought about that.
Yeah.
Actually, I'm only 21 years old. It's just I've been a change manager most of my life that I look like this.
Oh, please, the lady there, please.
Hi, my name is Kesey Fenton and I'm an entrepreneur. I've worked in many industries from construction to shipping to now in healthcare. I'm currently in data analyst in intelligence as I speak. What I've just my 2 pence in it, I think when you're trying to build trust on a certain level, I think a good way to start is looking at the fear of the user. What are they fearing? What is it that they are scared of? And then building the trust around that. My question though is, well, what I've noticed, I feel like Orbital is going to be super efficient, and I was wondering if has there been any insight on how this may displace some human impacts, and how is that being looked at in the future?
Please, Ella, you answer that.
So thus far in our interactions with our partners and our clients and our users, it is purely a super intelligent partner for their work. This hasn't necessarily been envisioned as a pure, like a one-for-one replacement for something, right? Like the agentic nature of Orbital is not actually going to say, now I'm going to do this and I don't need you anymore. It works in concert, in partnership with the users at the front line. And yeah, so that hasn't necessarily been an impact of Orbital we've seen thus far.
If you want a broader response to this for a second, so we are in a relatively, you see HR is not a problem here in terms of the cost structure. That's not where the money is being spent. If we want a realistic view for 2 seconds about what AI is going to do, if you look at insurance claims processing, right? We can score an insurance claim to probably 98, 99% accuracy within 10 weeks with AI and move to straight through processing on 90+% of claims today. That's a huge employment industry. Whatever people say about humans in the loop, the reality is most of these things will be scored and processed automatically, and then they'll be elevated to very high quality humans who will deal with edge cases. So AI is an empowerment tool like we've never seen before. It may help us save the planet. We could destroy it too. Who the fuck knows? Depends on your probability of doom. But you know, it's incredible.
Excellent
right?
salesmanship, Fred.
It's gonna drive advances in human flourishing, human longevity, etc. And in insurance claim processing or banking middle office or something, you can get rid of 90% of people. Like whatever lipstick people put on the pig, we've handed corporations the biggest cost-saving tool in the history of mankind. What do you think is going to happen? So I think we have to hold the reality of both these things in our mind and look at the societal displacement. It is not a particular problem here. I think about it all the time. We have companies in the portfolio that will have significant impact on employment for sure. This one, you know, we're not talking about large population groups, so it's not really a big deal. And I think the environmental benefits are so outweigh anything that might happen on the employment side that the real question is, can we deliver on energy efficiency at scale? Because if we can, you know, the net impact on species on the planet overall is really great.
Sure. I have time for one more question before I go back, please, the gentleman there.
Uh-oh.
Thank you.
Make it a good one.
I'm Dima. Last 7 years researched carbon materials and also making computer models. So my question is, it's not a big secret that the AI models make some mistakes during the calculation. So how is possible to find the mistake in such a sensitive data we need in this field? And is it a problem or not for you?
I sort of want to bat this one to the demo because I think we could maybe put a pin in it and ask Sam or whoever's demoing to answer specifically that question, because they could probably show you in real time, you know, how you ensure safety of the recommendations and how they're checked for sanity and accuracy, etc. So I think I kind of want to park that a little bit because I think they'll do a better job than we will, if that's okay.
Okay.
Is that acceptable?
Yeah.
Yes. Okay.
There's okay, a quick one. We can take a quick question, please. Just.
Hi, I'm Walid. I'm currently studying at Imperial. This question was specifically for Fred. You mentioned market risk, market timing risk being a huge factor for you. Very quickly, what does the time horizon look like for you, and what are some of the key milestones you envision applied computing hitting for you to realize that?
It's a great question. So here's what's interesting in the process of seeing applied computing unfold. We started with predictive maintenance as the problem, and very quickly realized, oh, wait a minute, we can actually do whole system optimization. Cool. Oh, wait a minute, we don't need to label the data. This is not limited to oil production. Cool. And so it's one of these rare companies where you start looking at that thing and then it goes. So the problem right now is one of it's a good problem, is one of focus to make sure that we are serving our customers the best possible way. So there are obvious use cases in refineries, but we're seeing them in gas, we're seeing them in upstream, we're seeing them in carbon capture. And so it's kind of looking at a myriad of things and then going, where do we apply the resources we have internally? How can we hire against, this becomes a talent issue, which is can we hire enough high quality people? We're very grateful to have Harry, etc. join, but can we hire enough quality people to go serve those folks? Can we deploy people in the field alongside them? So I will tell you that the future is unpredictable, that in startup land, whatever milestones are designed are good objectives, they're nice poetry, and then we go hit the real world and we realize that the poetry was poetry, and then we align on the fly. So at the moment, I think it's like, how many pilots do we have? A number. I don't know how many company discloses. Do we bring them to shore in a safe way with good client results? And then when do we decide to scale? Deciding when to scale is one of the hardest decisions in venture capital. My bias is always, let's make sure the pillars are built. It's better to scale later than to scale prematurely. So let's make sure the pillars are built, we have the talent in place, the results are solid. We are in mission critical environments, so this is a game of, we're not designing shit and see if it sticks. Like, we are designing industrial grade, energy grade systems. So slow is good, deliberate is good. And so my milestones will follow the reality of the field. If that's kind of a non-answer to your question, it's actually the honest answer.
Absolutely. This brings our Q&A to a close, ladies and gentlemen. I think we turn our thoughts to some of the takeaways from this session. And Fred, I'll leave the floor with you for starters, your closing thoughts and your takeaways from the profound discussion we've had this afternoon.
I mean, I've spoken a lot. I just feel a little bit inspired to say that, how we relate to AI and what we do with it is the defining problem of our time. And within that, what we do with energy it may hold the keys to our future as a species. So I think there is what we do as a company and all that jazz, and then there is this deep sense of urgency within me to go, man, we have a multivariate, complex polycrisis problem to go solve. This is no joke. And I think in terms of our moral ambition and what we do in the world, it's like, let's just go solve it now. This is a time when this is not a time for me to think about my career risk and my reputation, etc. Like, no. We have a dramatic set of issues on our hands, and it's like, where were you at the time when this happened, and what did you do? Is where my mind goes, and I think energy is a big part of that problem in that equation.
Elisa, over to you.
The unenviable position of following that. And also consciousness that shortly with Sam we will be giving the product demo. So perhaps I will simply say, with the helpful perspective from industry you provide of how difficult it is to integrate these things in the past, the urgency with which we must attack the problem and the team is very clear to me, and I'm very motivated by the team we have to do it. I'm going to give a demo in like 10 minutes.
Fair enough. Over to Rika then.
Well, we're already at 1.1 degree global average. We're heading towards above 3 degrees. We cannot sit on our laurels. There's this sense of urgency. And with AI, I actually think we've been given a tool that can actually help us accelerate. Despite all the geopolitical nonsense that's ongoing, there is a momentum in the energy space of solving this. There's a momentum among investors to solving this. And this is an extra piece of the puzzle that can actually help us do it.
Kerry, bring this pragmatic conversation, if I may say so, to a close. Final word to you.
Yeah, anything that can help me do my job with big industrial clients will be great. No, I haven't seen the product and haven't seen it working, so I'm really looking forward to the demo. But 15 years at Shell, and you do get trained and you do get inducted in looking at some of those really big problems and existential crisis of energy on the planet, and then you go out to these places and you see the impact that some of these big industrial companies are having. So anything that takes us there. So I'm hopeful about the potential for AI. I hear nothing but positive stuff about orbital. I'd really like to see that. Something which can game change in this space would be great.
Thank you, and thank you to all of you. A round of applause for our eminent panelists.